Okay, so just a second to understand. Again, I'm a little bit checking the situation. So, am I live? Yes, it requires some extra time to understand how to navigate through this, all the processes. So sorry about this, but at least I hope you can see me and hear me. Okay, yes, it's alive. So this is a good news. And what we will do now, I will just switch off here the music. Yes, so we'll do like this. Yes, and sometimes I will return to that screen as well, just to double check. Also, we need to, again, like a bit of preparations during our live stream, so everything will be in accordance with the guidelines from very experienced YouTubers who do these live streams on daily, hourly basis. They are demonstrating everything in different areas of life. So regarding our live stream, we are doing only AI in agriculture, and specifically we are we have this live stream not training, but how to say correctly. We are doing just checking how the AI systems are working with real live data from agricultural field. And today we will do blueberries, because last time we have done some experiment with germination rate count, germination rate assessment, and also germinated cells count and non-germinated cells count. Yes, and it was nice experiment. So we will continue to do this in the future. And as of now, the next available experiment for us is to count blueberries. But we will not count blueberries in my nice bowl. We will count blueberries in the photo. But until that time, we will still do some general overview of the experiment which we have today. So first of all, yes, as usual, this is the experiment which has been published already. So results are known. But what we have discovered, and on some stage I will go to the next screen, but I hope, again, I really apologize for giving you a lot of these technical screens. Maybe it's not a very good idea, but as of now I just don't know how to navigate quickly and invisibly. So later on, I hope I will be more proficient in switching between screens without showing everything. But as of now, yeah, just this is the reality of streaming. Yes, and yeah, using the smartphone, it's much easier now. I'm a little bit better with streaming using the smartphone, but regarding desktop is still kind, like, especially when we need to switch between these demonstrations. Anyway, let's go to the subject. So, but yeah, first of all, regarding the problem, why do we need to count the blueberries? Again, I already have the recording. I have already recorded the videos with the blueberries count and why it's important. It's all about the first step of yield prediction and yield or yield forecasting, or whatever you need to, yield planning, maybe you call it. It depends on the locality and culture, but all the results are leading to the same point. So you need to understand how much yield you will have at the end of the season, and starting from the earliest possible stage, when you have the first buds. Sometimes snow is still covering the land, and yeah, there is still winter or maybe early spring, but you already have a chance to count future yield and predict it. And this is where the computer vision and deep learning can help. And currently, computer vision and deep learning are good and accurate in terms of counting buds, then flowers, then fruits on different stages of their ripening. So additionally, if you will add on top the information about the environment where these fruits are grown, you also can build this ripening curve. So you can see and predict, and maybe not you, but even your algorithms can help you to be more accurate in understanding when the harvest will be ready to pick up. Yes, I understand there are variables from the climate and varieties, but at least it will provide you more specific window, so you can plan your labor, you can plan your transport, logistics, I mean, everything which needed, not just to carry the fruits from the orchard or field to the pack house or where you need to process them further for the distribution. And also even marketing, because you can understand the amount, so you can prepare yourself for specific messages, for specific negotiations. And yeah, just knowing numbers is always helpful when you are working with some kind of harvest which is produced from the crop system. And regarding blueberries, basically we work with blueberries because we have a real life experience of working with them and the real farm which is growing them. But the same idea can be applicable for other soft fruits and other berries specifically. And yes, it was last week, I think, yes, 19th and 20th of March, as I remember. Yes, it was the Fruitnet Berry Congress in London, in Canary Wharf, a very nice location called Polygon, as I remember. Sorry, because sometimes it's just a lot of information, so yeah, very easy to forget. But as I remember, it was Polygon, and it's a very beautiful venue, and it looks like a big greenhouse because it's from glass and steel and some concrete. So, and yes, obviously it was a high level event, and so many interesting insights have been learned from this event. I already prepared some textual contribution. I prepared the newsletter about the berry industry and 5 insights which I got from this conference, not conference, but Congress, Berry Congress, yes. And also I prepared some visual video about my experience during this day. Yes, there was a second day as well, and we went to DP World, which is the logistics center, and it's the port, actually, big port, which is the gateway to London. So all the blueberries from Morocco came to this point, and then they are distributed further. But I didn't still publish anything on that point. Oh, I see. Yes, I already went straight forward to the point of speaking about the subject, but I forgot about housekeeping points. Last time I was very good on this, but now you see, not according to the agenda. So quick housekeeping points. First of all, there is a comment side on the right. So you understand where is the comment side. So you can leave your comments over there, and on some stage I hope to check them if I will not forget, but I will do my best not to forget. Anyway, please write me something over there, and I will definitely read it either during this live stream or afterwards. And also another housekeeping point that yes, we will have some breaks every 15 minutes when I will remind what is the subject of what we are doing here, because it's just a very experienced advice from these all YouTubers who are saying that people are coming and leaving. So the person who is doing the live stream needs to remind the subject. And yes, obviously, if it's a gamer, so probably there is a obvious understanding what's going on. But in our intellectual live stream, we definitely need to remind, because I understand if the person is joining like in the middle when I am asking Grok for specific, or not Grok, but some other AI assistant for specific output, that it may be not very straightforward and clear what we are doing here. So, but we have we set a timer, so we are not thinking too much about that. Going back to Fruitnet Berry Congress and the results of it, so it's very interesting, because actually I got a YouTube comment that I need to add additional layer of like some useful experiences, knowledge, not just demonstrate the video of what have been happened during the Congress. And as I mentioned in my response, that I obviously do some in LinkedIn, and even in YouTube there is a nice part called community. So I do my best to update it regularly with some interesting, in my opinion, interesting contributions. So maybe it will be complementary to the overall experience gained in my channel. So if you wish to know more about some video or some experience which I demonstrated in video, I do apologize, unexpected sound. So then please go to the community part, and there is some explanation. Yes, and I think it's actually the final point about intro part, about the problem and what we are doing here and why we are doing here. Now we will go to the technical side, and I will explain what the input of our today's exercise. We will call it exercise. And now this is a fingers crossed moment, because I will switch the screens. And last time it didn't go smoothly, so I really hope that today it will be better. And if I will disappear from the screen, please stay here. I will appear on some time, on some moment. So let's just do the magic. And yes, and then I will also double check the. Okay, I see already the challenge. So I will. Just a second. I will remove this. Yeah, so on some stage, I need to learn how to do this without disturbing your attention with this. So I need the video capture. Okay, hopefully now we will be, oh yes, I think it will be nice now. So we will make this size of screen and like that. Oh, no, sorry. Yeah, like that. So now you can see me. I don't see you, but I can read your comments. So if you want to say something, please do the comments. And what we will start our. I'm just trying to understand. Do you see my screen still? Just a second. And also I will check audio, because I'm not sure that. Oh yes, I see that everything is all right. So you can see me, and you can see my my everything, my screen as well. And yes, I forgot. I was preparing for today for today's live stream, but I forgot to switch on the music. So maybe next time I will be even more prepared, and the music will be here. And yes, I just don't want to break this fragile system and try to experiment now. So because yeah, my first this type of live stream was pretty okay, but then when I was rewatching and analyzing it, I saw that some challenges. So I hope next will be better. Anyway, let's go. So what do we have in this folder? It's just prepared for today. So first of all, I will show you the result, which has been, as I mentioned, has been published on LinkedIn, and it's about my results of asking AI about blueberry count and size measurement. Oh, can I do it like in full screen? Just a second. Oh, I think this is better. So this is the cover of, and you can see obviously these blueberries. And also, by the way, the blueberries are according to the latest trends, all this marketing for berries and everything. Blueberries are permissible indulgence. So if on some stage I will be just eating these blueberries straight here in live stream, please forgive me, because sometimes we just need extra energy to continue this live stream. So, but as of now, I am enjoying these blueberries which are on my screen, and you see the mosaic. It includes the blueberries which are grouped and sorted by their sizes. So yes, this is the first page, and then we go to the benchmark. So in our photo, again, maybe I still need to think about the protocol, what I am showing first and then what I'm showing second. So I will show you now the photo, because obviously if you have never seen that photo, you don't understand which blueberries. Oh, here is the reminder, and the reminder is about that we are reminder what we are doing here. So we are doing here the test of AI assistance in terms of the accuracy and the results of counting and measurements of blueberries using the photo taken with a smartphone camera. So it's RGB photo. And now I am on my way to the file which was analyzed. So this is the file which we have shown to the systems, AI systems, and here you can see the blueberries, and even I see some was squashed here on the left hand side on the top of the screen. You can see it. Also, we have the calibrating plate, and basically I think it's the nice way to show and how it works. So here is the calibrating plate, and this calibrating plate basically any computer vision system for measurement, they need some reference. So this calibrating plate is the reference. You can see it on the screen. And what does why it's important? Because, and you see it's a special calibrating plate from Petiole Pro, because we designed it and we patented it, so it has a design patent, and we use it for our pipeline of imagery processing. And yes, it has ArUco markers. This is this black-white squares. They are called ArUco markers. I don't have a ruler next to me, but the size, it's a square, so it's not a rectangle and triangle. It's a square with a size 15 millimeters. Why this is important? Because this reference we are providing in the prompt, so the systems will be able to use it as a reference for size measurement. We believe it's possible to do it because we have done it. So now you have seen the photos, and going in front of our PDF, it's 229 berries. And let's go back to the PDF. So I have shown this, and now let's go to the PDF. No, it's not PDF, here. So as a result, you can see everything what has been done. So we have, and here is the reference about the ArUco markers as well. Here, the 15 millimeters ArUco marker reference you have seen. So 229, we remember this number because it's important to see the accuracy of counting done by AI system, as well as other key metrics which we have measured. So using that ArUco marker, which I mentioned with this 15 millimeter reference, it's possible to measure the area of each berry and then calculate mean area. So mean area, mean parameter, area parameter, sorry, not parameter, area perimeter correlation. It's all about statistical analysis. So we are not explaining how to do it because you can go to basics of statistics and learn how to do it. And moreover, all the systems which we are testing today, I mean AI systems, they know how to do it. So that's why we are not going in depth regarding this part. We just checking the accuracy of counting the numbers. And in our case, we have the mean area 2.16 square centimeters. Then we have mean perimeter 5.54 centimeters, not square centimeters, yes, because just area is what's covered all, and the perimeter is all around like a line. So that's why line is only in centimeters or millimeters, but never in square centimeters. And then area perimeter correlation is based on the two numbers which we get here. Good. This is our benchmark. And also I prepared to show you, because last time when we were doing the germination rate, I didn't show you the CSV and all the files which I had. So today I am better, I'm improving regarding the preparation. So what I have else, will check like this, what I have else. So I have this report, and this is the CSV file, which includes the count for each berry. You can see that we started with blueberries 0, because I think you know, but if not, all these computer systems, they start everything with, not with 1, but with 0. And that's why, and also what we have also, we have image name. This is how the name of this image which was analyzed, and detection ID, contour area, and perimeter, and units. Good. And here we have all the 229, as you can see. Yes, because it's ended with 228 at the same time. Since we are starting with 0, everything is all right, so it's 229. And the third parameter, which is area perimeter ratio correlation, we are calculating based on these numbers which we already got. Okay, so this is our report which exists, and this is our prompt. But maybe I have something else to show you. And this is the statistics, so which we got using this data of CSV file in different variations, what can be done, and different application of this statistical analysis which I mentioned. And also, what else? And also we have this mosaic, which I put in the first page of the PDF report, but here it's in clear way, so you can enjoy each fruit. You see that the largest one, and even the squashed one, which was on the top left corner, it's still here. And even the smallest one are here. But sometimes, you know, this is also the point of data collection and following the protocol, that if there are some shades, like strong light on the object, which or objects which has to be analyzed, because sometimes we're analyzing a leaf, but sometimes we're analyzing 229 blueberries. So it's still the rules are the same, so we need to follow the nice light protocol without these strong shades, because if the strong shade present, then it's the chance that the area will be calculated incorrectly. So that's why it's better to have this with this, I forgot this word how it calls, but I mean that not diluted light. There is another nice word which explains this. The light should be spreaded evenly on the objects which has to be then captured and analyzed. Good. This is the one mosaic, and also this is another mosaic, kind AI art, but it's not actually any art. It's a real processed file by one of the models. So this is the same blueberries, and if we go back to this, so even you see the sizes, and maybe I can, no, it's already, it is a result, here. So here you see, it's just like turning the background as well as different colors. Yes, I think it's the final point here, because this one, I will just, a small teaser, this is Gemini. Last time, maybe this time we will have a different thing, but this is what has been counted by Gemini, but it's included into the report. So we will look at this also. Where is my report? Oh, here. Yes, so we have this benchmark, this verified by a human. Me was a human, so verified. I can confirm it's verified. And let's go to the next. Who is next? Oh, no, I don't want this. I want, just a second. Yes, and this is the prompt. So we asked about this. Actually, I put it into the file, so we will copy paste. And the results. So let's keep it one by one. So we have started with ChatGPT last time, and also, as we can see here, the ChatGPT last time was thinking for 8 minutes 40 seconds, and also what is important, that it has discovered 283 berries with some 0.57. It's in mean area, but here it's 216, and then we have 323 perimeter, but here we have 554, so not absolutely accurate. And then we also have this correlation based on these numbers, but obviously the same situation like with germination rate, when the germinated cells and non-germinated cells and overall count is not counted correctly, then no way to get the right result of something which is based on this number. So area perimeter correlation was not correct. But also what we discovered last time, that these systems, they provide different results every time. So only, as I remember, Copilot was stable in terms of providing the same count both times, and someone else, Claude, as I remember. But I mean that ChatGPT was wrong, because both time different numbers, and both times it was wrong count. So that's why let's do it now, and let's check what does ChatGPT think. Okay, no, this one. Just a second. Yes, this one. Okay, so what ChatGPT thinks about our task for today. So as usual, I'm doing this copy paste, and last time, another thing which I want to point here, I was thinking about this during the week, that I read somewhere that we need to use different prompts for different systems, because they are adapted for different structure and logic of prompts. Yeah, maybe that's true, but in our case, first of all, sometimes it sounds like marketing. Honestly, they are trying to, these guys who are telling this, they're just trying to sell their expertise in prompt engineering, because it's kind of like cool job now, and everyone wants to do cool prompts. So that's why I don't trust them, honestly, very much, because in most of the cases, when you need to get job done, you can do the same prompt in different systems, and it's not only about counting or measurements. You can do it with even some language task or some other things. Yeah, soon I will give you more details on this, but I will not give too much details now. The time will show you what I have prepared for you. So we are copying this prompt and go to ChatGPT. And here we are also adding our nice photo which you have shown, which you have seen in downloads. Oh no, not that blueberry. It's an archive which I have. I need another blueberry. No, germination blueberry. Yeah, here. And this is our blueberries. Let's just double check. So it will not be something fail. No, it's not mosaic. We need original photo. And how it's original, because you see the size is 1.07 megabytes. So it's still real photo. It's not that I have cropped it from something. It's a real photo taken using a smartphone. And also add. So now we are asking to count all blueberries in the image using the 15mm ArUco reference marker for spatial calibration, measure each blueberry and report total count, mean area in square centimeters, mean perimeter in centimeters, and area perimeter correlation. And please exclude the marker and non-blueberry artifacts. Yes, so sounds like a very reasonable prompt. Start. So the process has been started, and now we have a nice time to drink tea. But I see that my cup is too far, so yeah, I will just maybe eat some blueberry, because I already announced that blueberries are permissible indulgence. So really now I will tell you about this permissible indulgence. I will eat one of it. Very delicious. I didn't check, is it from South Africa, Peru, Morocco, or where these blueberries came from, but they are very nice. And why I'm holding this smartphone now, give me a second, I will put my reminder again. So we have every 15 minutes I'm reminding what we are doing here, because it's just an advice from very experienced people who are doing these YouTube streams. And this is very good advice, I think, because coming, leaving the stream, it's a live situation, especially for Saturday evening. I know that it's very nice time for relaxation, entertainment, education, and other nice things to do in life. So I'm grateful for you for joining my live stream now. We are doing blueberries today, but not only eating. Yeah, the technologies are on that level that I cannot share these blueberries with you, but I honestly want to share them with you. And one day maybe we'll have some, I don't know, something, and then I can share them. But also we are doing the measurements and count of blueberries, and I see that our nice ChatGPT has already provided some results. So let's check, what do we have? I'll be transparent. Doing the fully accurate account per berry measurement from this single image requires careful segmentation. Obviously, careful segmentation. This is probably the keyword which we need to put on the wall and just learn it and remember, because what is segmentation? When you have these photos, not just my photo which I have added as input, but also any photo which should be processed by computer vision. The first stage is to segment and to see the objects which has to be counted, assessed, or processed in any way. So yes, careful segmentation, good, very good point. That isn't reliable with quick automated methods. Here the berries overlap, lighting is uneven. Well, you see, this is what I mentioned when I was speaking about the strong shadows. We need to avoid them. And the tray is similar in tone. Another point, yes, I also thought about this, that probably on some stage we need to do easier examples, because this is the just difficult thing, because dark berries were pictured on the dark background, and this makes the task more difficult, because you can as a human, you still need to do extra effort to separate the berries from the background, And if you're a computer, if you're a system, it requires, I suggest, even more efforts. So that's why next time I hope to do something in easier way and not to do so difficult things for our AI systems, because they are already so good. We should not overload them with very difficult tasks. Let's just give them something more easier to demonstrate their full capabilities. Anyway, go to spatial calibration. They are explaining. This is nice thing regarding the systems, that they are explaining what they have done and the reasoning behind every number. In most cases they explain. ChatGPT is always explaining. Other systems so but ChatGPT is always explaining which size reference he was using and for what. Blueberry count, using density estimation and partial detection and visual verification. Oh my god, these words, it requires extra brain effort to understand what does this mean, everything, but yes, it's okay. Total blueberries, we are interested in this. So 275 plus minus 15. Let's go to our 229 as I remember, but let's double check. So 229, so this means that even, let's consider the first situation, so it's plus, it's 275 plus 15. It will be 290, it's not correct. And if we will minus, so 275 minus 15, it will be 260, still not correct. And this is already the issue, because going back to our PDF last time, it was 283. So again, maybe it's just the improvement of the algorithm, the model, because let's see what we are using now. We are using ChatGPT plus, no, not plus. Plus is requires to upgrade, but we are using ordinary ChatGPT, great for everyday tasks. Maybe the counting is not everyday task, but however, I'm not sure what else is everyday task if not just simple counting. Okay, I understand maybe the measurement is more complicated, but counting, it sounds like, you know, count everything, counting, basic operation. Let's go further. So size measurement, calibrated. From sampling multiple clearly separated berries, typical diameter is 9-11 millimeters, mean radius 0.5, so okay. So mean area 0.75, 0.85, and in our case, which we have, no, even regarding area, the numbers, when I was doing this experiment by myself, the area was different, and the perimeter 3 and 3, but perimeter is pretty the same. It's kind of like consistent. We can say that it's consistent because 3.23 is somewhere not too far from 3.15 as its central estimate. But again, going back to our PDF, it's not the right, because actually the mean perimeter is 554. It's not 3 but more. And again, the area perimeter correlation is not correct as well, because as we see the one parameter is similar here. Yes, this is ChatGPT. So that's why we see that, okay, thank you ChatGPT for the results, but this is kind of already the second time when we get the numbers which are not even close with the results which we got from previous time. And again, they are not correct in this specific task. And maybe the problem is that ChatGPT has never seen the berries in this setup with this kind of task and these ArUco markers to measure. At the same time, yeah, I will think how to simplify again. I see that we cannot go further on doing very complicated things which we actually require to do for production level, because this is the photo which is taken for quality control of blueberries, when you need to do the visual quality control and visual assessment, and you are counting, then you are measuring the berries, as well as you are doing the separation of this non-berry or abnormal berries. Like abnormal, I mean that either it's abnormal in development, like unripe, or misshape, or maybe there are some other objects even which are not berries, or it's presence of obvious damage for berries, like we have this one squashed berry. So it's all about visual assessment, and it's actually can be done with computer vision and deep learning. So I understand it's kind not everyday task, but at least my expectation that counting should be on some proper level, or at least with minor mistake, but count 275 berries, which in reality is 229, and which is it's 46 berries more. It's quite a lot. No, I can't do this very quick process in my brain. What is the percentage? 46 berries out of 229, but it's definitely a lot. Yeah, let's just do it further on and go to Gemini. Gemini task the same. Oh no, I don't need this. I need this. So I will not read the creating. Are we creating? Oh no, we are uploading. We are uploading again our nice photo, not mosaic. We are uploading this blueberries, which are we had the same for we have done the same for ChatGPT, and maybe we need to change thinking mode, or even pro mode. Oh my god, we have such a huge selection what to but let's see what we have used in our and we forgot to ask. Okay, I will ask now, so just give me a second. I will give the task for Gemini, and then we will go back to ChatGPT. And here we have used the thinking mode. Okay, we will be consistent, and we will be using the thinking mode again. So input the same. Let's do it. Good. And in the meantime, let's go to ChatGPT and ask, can you show us, so what is this? It's detected object, so it's kind of show us detection. Yes, and I forgot you to show this. On the left hand side we have the detection done by our Petiole Pro, and on the right hand side it's detection done by ChatGPT last time. So let's just ask about the detection, how the detection of the berries looks like in this photo. So hopefully we will get some visual result in terms of imagery, because last time when I was asking something similar, we got the textual output, sorry. Yeah, I do apologize about sometimes it's already almost 9 p.m. in the UK, and after windy and cold but still very beautiful day, this file is no longer available. Okay, let's give me iron quick circle based. Okay, let's see what do we have. It just show us some magic or not. Download the detection. Oh, we will have. Oh wow. Okay, it's a new artifact. I need to save it. Save it just to save it for the future. So blueberry detection, ChatGPT, and then we are writing what is the date today. It's the 28th of 26. Good. Nice. And so you can see that it's kind of nonsense. I hope it looked better, but yes, maybe maybe paid versions will be more accurate, because as of now it doesn't bring any value. That imagery, which was, first of all, it was very quick, because how long does it take this time for him to do we have time? No, this time we don't have, because previously ChatGPT was writing how long does it take to process this imagery, but as of now we see that no time, and plus this generation of result was quite just tick the box. It was not without it was done without any care, and the visual result which we got is the proof. Now let's go to Gemini. Slow show thinking. I encountered an error during this. Okay, let's ask again. Let's ask again and do the same tasks again, just to double check, so that they have the same photo, the same prompt. And yes, maybe switching to the other screen, this is the reason why there was a problem. So now we will not switch the screen, but we will sit and look on the thinking process. And here we even can see what's going on and how the magic happens, and that it's not a black box anymore, but we can see what has been. Again, 15 minutes. Oh my god, time flies. Again, this is the reminder for me, just to remind you that we are doing the test, crash test, let's call it crash test of AI assistants on measurements and counting of specific objects in imagery collected using the RGB cameras. In our case, it was the blueberry image. The image with blueberries, with 229 blueberries. Here it is. Yes, I will not show it fully because I've already done it, and at some stage in the future I will open it again. But we are already tested. Something went wrong. Okay, let's just start a new chat. Maybe there will be some better output if we will start new chat. Then we will add the photo. So here is our photo, and then we are adding the same prompt for all our systems. Let's do it, and hopefully we will get some result from Gemini, because from ChatGPT we already got the response, but unfortunately it was as before. As before, it means that we get the same approach with wrong numbers in counting, and also not absolutely right results with perimeter and also the area of berries. And as a result, the area perimeter correlation was also calculated in the wrong way. So now we are waiting for the results from our another assistant, Gemini. And just in case if you are interested, Gemini has other nice opportunities to work with it. And recently they added, I mean Google, because Gemini is owned by Google, and this is the trend for all the big giants, technological giants, to own their own system, AI assistant and model. So for OpenAI we have ChatGPT, for Google we have Gemini, and also Gemini can already generate imagery, videos, as I remember. We can just check what else can be done. Tools here. So it has create image. It's nano banana, very nice, thin and yes, very realistic imagery can be generated. Specifically, I remember when the nano banana movement had started, all the internet was like, wow, it's such a realistic image generation. So music, guided learning, deep research, canvas, okay. So, you know, they are adding all the time. Oh, yes, we have the results. So they're adding all the time the new experiences and new possibilities. So the main thing that music is already added. I was like, wow, unexpectedly. So this is kind of new point in comparison what is done by other assistants. Check what they have done. The reference about 15 millimeters ArUco marker. Total count 170. Wrong. Main area 0.67. I need to check. Mean perimeter also they see not very correct, but let's see here. And yes, as you can see, ChatGPT in comparison with what we have now got like, oh my god, it's such a different point. So mean area 216 and mean perimeter is 554. 216 and 554. 216 and 554. No, it's not correct. And let's check what was last time. Last time for so we are actually checking the accuracy in comparison with benchmark, and also we are checking the consistency of results, because as I mentioned, this experiment has been done by me earlier, and I already see the numbers and I see, oh my god, last time it was 309. Okay, but now we have 170, and then the mean area was this, and mean perimeter was this, and then correlation is different as well. But no, we will not go like in very depth analytics and these numbers. Let's just ask the same as we have asked ChatGPT, and ask about image. So we would like to see how this detection has been done, because I suggest, as I already have shown you, the image is present, but we will not go to another window. Just let's keep the same window now, tab, and then we will because last time Gemini, it was as I remember, it was kernel with kernel count. Then we had such an interesting image. What now? Here is visualization of how the computer vision system. Oh wow, you see, it's very accurate, I must say. But why 170? Let's just try to understand why. Because as you see, the segmentation was done very nicely. So let's open it. And the quality of image is very good as well. 2.3 megabytes. As far as I see, the berries are correctly segmented. So class blueberry, here is the result, 291. Yeah, we actually can do manual verification. So, and this is how the human in the loop works. So when the human is sitting and just counting the berries by human abilities, not using computer. But I mean that from the first look, it looks like they counted all the berries, but still not clear why we have 170. But this is a new visualization, because last time we got this one, and you can see the improvements actually, how and this is, as I mentioned, this is from Petiole Pro. We also have done our, oh no, we will not do this, we will do like this. So we also have done the pointing with dots, what has been measured. And last time Gemini was demonstrating the count on each berry. So you can see the numbers of berries which were counted. Anyway, as we see, the numbers are not correct in comparison with the benchmark, neither that time nor this time. Good. Next, we have Claude. Our very good Claude is here. And now, no, not this prompt, but we need to save it for the next question which we will ask him. So here we are. This is the prompt, and this is the image, our nice image. Sonnet. We are using Sonnet 4.6 or Haiku 4.5. As I remember, it was Sonnet, but let's double check. Yes, it was Sonnet 4.6. So let's go back to this model. All the same, good. Yes, and as I mentioned last time, this Marina returns, it feels like such a nice greeting of me. So like, hello Marina, nice to meet you. So hello Claude. Okay, let's see. The process is ongoing now, so we will not disturb him. Yes, but so you can now in real time you can see how the systems are changing, because I did this experiment not so long time ago. I did it like a week or two ago, and at that moment we had again different numbers and different segmentation, and even yes, the approach how to visualize the segmentation. For example, specifically for Gemini and even for ChatGPT, they were absolutely different. But now we see some improvements in terms of, for Gemini, it's visualization, because this is kind of masterpiece, I think, in terms of how accurate and nicely looking it is, and the design. The only thing, what do they have? ArUco target detection success dictionary. Okay, marker IDs, 5 markers, and calibrated scale. So you see they have separately, as we prompted it before. So we asked not to include the reference. So this is the reference. So it's excluded, and you see the bounding box, red bounding box, and here we have our roundish bounding boxes. And another very beautiful point that in some berries, you see the shape is even not circle but oval, and the system is following the shape, even not oval but some more abstract circular shape. And here, for example, in this blueberry, you can clearly see that more than a berry, or not, maybe this is the berry, but this is what I mentioned regarding the taking photos on the same color background. It's difficult to separate background from the berries or any other objects which you need to count, to detect and count. And also regarding the shadow is somewhere, I think, for example, here. It's kind not absolutely 100% taken with berries, but with some extra shadow. And this is our squished berries still counted. Yes, it's just a separate area to research how it works in terms of accuracy of this segmentation. But let's go to Claude. Oh, Claude is still thinking. Want to be notified when Claude responds? Oh, it's another point of customer satisfaction. When you see the Claude now not only speaks to me and saying my name, but also it's asking me, how do you think? Is it convenient for you if I will notify you when I will finish? Okay, let's ask him to notify. But it requires now this add-ons to allow, and we will not do this now. I will do it by myself. Anyway, let's wait more, because since it's working and it takes time, last time when we had our, do we have time? No, we don't have time, but I remember it required like 5 minutes at least. So let's give him some time. And this is the explanation which I quoted here in the PDF, that heavily touching or partially occluded berries in the densest interior region may account for +10 or plus minus 10, plus minus 15 undercounts. So, you know, it's actually, if considering this idea, it's possible to say that it was pretty close, because 52 minus 15, it will be not far from 229, which is actually the count of our berries. So, but again, it was not straightforward said by the system that this is the count. Okay, do we have anything? Final circle, carefully tuned. This is again why Claude is such a preferred system, AI assistant for coding and engineering tasks, because of this beauty of the process. Other systems are good as well at the same time, and specifically the systems which are embedded into the coding environment, specifically for GitHub, they have their own. For other organizations, they have their own, which is working within this environment. But for Claude, it's already well known that Claude is one of the leaders in doing this programming and engineering jobs, and explaining what has been done and why it has been done. And this is the difference between Claude and other systems, because when they have just appeared, it's another reminder to remind you what we are doing here. So we are doing here the analysis of how accurate and how the consistent is the result of counting and measurements of blueberries by AI assistants, presently available, publicly available AI assistants called ChatGPT, Gemini, Grok, Grok not yet, Claude, Copilot, and Grok, 5. And yes, I wanted to also include some others, but sorry guys, not this time. I had an idea how we can get more with more interesting setup for demonstration how it works in reality. Yeah, so we are trying to see based on the PDF file which has been I published it as a part of I Asked AI. This is the series which I run in LinkedIn, and I ask AI different questions regarding the AI in agriculture matter and some subject from AI in agriculture area. And then these systems, they are giving me the result, and I am comparing that result either with real life imagery, like we have done the comparison of the imagery generated by the AI systems for apple scab, for false codling moss, late potato blight. I see this and I forgot what I wanted to say next. Yes, but I still remember we also compared the reality of spruce seedlings. But let's go to Claude. Claude, 208 berries. And already visualized, we don't need to use our second prompt now, because I need to save it. Okay, and now we just add here the Claude. And by the way, did I add Gemini? I think I did, but I just need to do it again here. So you see how fruitful is the results of today, because last time when I was doing this, the systems didn't provide me any visual. Just a few of them provided, but Claude definitely didn't provide. I will show you. I will show you what I get. This is the Claude, and that's it. I didn't get any visualization of counting. But today, it's still not correct. But look at these beautiful colors. And again, you can see that I just don't know why the colors are different, first of all, for the same counted objects, because we were not asking about the stage of ripeness, we were just asking about the count. But as of now, like I see the orange or amber, let's call it amber color, and some blue, or maybe purple, not purple, but kind of like royal navy, something in between. And also we have this yellow segmentation for our calibrating plate, and this is a nice thing. At least this is visual separation of that we asked not to include the calibrating reference into the count, so we can see that it's separated. So it's not neither in amber nor in blue, but as you can see, it's just overcrowded, and that's why it's not correct. 208 is it's not the same, yeah. But again, overcrowded but not right, because the right count is 229, so it's not too much. It's just 21 berries more. But this is just, you see, some of the berries were not counted, some of them are overlapped, and the point here is that the bounding box, which is in circle, sometimes they are too big and they are overlapping each other, so that's why some of the berries are over covered with these bounding boxes, but some of the berries are not. And yeah, let's go to numbers regarding the measurements. Again, very nice clear explanation what has been measured and why these specific numbers were used. And here we see, so mean diameter 469. First of all, we are comparing with the benchmark. The benchmark is Petiole Pro. Here we have our benchmark. Mean area 216 square centimeters. Mean diameter, mean area 0.1787. 1787, it's not the 1787. Yes, because even if you will think about the size, so if this is 0.1787 square centimeters, it means that it's such a tiny object. It's even less than 1 centimeter, and most of the berries, now the berry breeders, they are hunting the size. Even if we will take I didn't show you, for those who have just joined, this is the bowl of permissible indulgence. This is how the berries look like and sound like now. So, but I mean that if you will take any berry, they are not 0.1 square centimeters in size. They are all already present. You can touch them, because something which is 0.1, it's probably difficult even to feel when you are taking it. So this is not right. And perimeter 1.474. Again, it's very small. Based on, obviously, on this mean area and perimeter, they are very linked to each other, but they are not correct. And let's see, what do we have here? Yes, perimeter was 5 centimeters, not 1. So 5 times less, the count from Claude. And obviously the correlation is wrong as well. Then let's see what was the last time. Maybe there are some. Okay, let's read notes, because what I like in Claude, that not only about the thinking process which is demonstrated, but also regarding some notes which can be okay, even the numbers are wrong, But these notes give extra feeling of how the methodology works. So that's why I like to read his notes. Count uncertainty. Obviously, as you see, he explains that it was uncertainty. Then size, median diameter is consistent with wild bilberry type of small cultivated blueberries. This is the wrong point, but at least it gives you an idea that wild and bilberry type of berries, they are small, so it's kind of an extra knowledge. I think it's beneficial. Area perimeter correlation. This is geometrically expected for approximately circular objects. This is another point regarding circular objects. As we discovered, even from very beautiful segmentation from Gemini, that some of berries are not perfect circle, and that's why counting this size matter, and that's why counting the shape, understanding the right shape matters a lot, because if you are suggesting that all berries are in perfect circle, then it's a wrong suggestion. And then final point, the calibration disk and one damaged reddish, very visible mid left were excluded. Oh my god, this is such a nice. So excluded the calibrating plate, and excluded, as I understand, excluded that berry which is squashed. So this is very good result. So as you see, the AI assistant is still working hard. So it's not just, it's just a little bit about specifics of the niche, but the right things has been mentioned. Good. Now let's see the consistency of the results. This is our Claude last time. Last time it was 0.725, but as you see it's less than we have counted now. Yes, and we will also have this notes analysis, so we can download everything and use them for in the future. So we have a mean area which is not consistent, because it's less than it was calculated before in last time, and mean perimeter again less, because our numbers which we got now, they are even less than those which were obtained last time, and this numbers was already less and wrong. But even going in a smaller scale, it doesn't add any value. So next, it's Copilot. Let's go to Copilot. Oh, the Copilot is funny because it was not able to do anything with our berries last time. But we are very persistent and we follow our line. So even last time Copilot was not ready. Today we are asking him again. So our traditional prompt. And now, do we use smart? I think we use smart. Smart, yes. Okay, good, smart. And I need to close this. Smart, and also our traditional photo of berries. Is it this? Yes, here we are. Traditional, because every chat, every AI assistant is working with this, the same photo. Let's start. The party start. I can help you think through how to approach this kind of measurement, but I can't directly come to measure. Oh my god, I think it's consistency. This is the point of consistency. He cannot help us. I can help you think through. Yes, you see, just the same words, even the same words. How to compute. And again, it's very strange, because when we had the task for other counting tasks, I mean for kernels, wheat kernels, as well as for germinated cells, it was able to count. But yes, it's negative result, because we don't get any results from Copilot, but it's absolutely 100% consistent result. Okay, thank you, Copilot. yes, Copilot is owned by Microsoft, so I think a lot of universities, big corporations, banks, so many guys who are working with Copilot already can understand the range of tasks which can be done. And as we see now, computer vision tasks are not one of the strongest ones. So you will know that, yeah, maybe there is a need to, or maybe there is a paid version as well. So you need to ask the paid version, because this is the free one. Good. And then I think it's the final guy who will ask today. It's Grok. And the Grok was answering, as I remember last time, our question. So where is Grok? Grok here or not? Where is Grok? Ah, here. Yeah, sorry about that. Yeah, it's already waiting for the task, and it's very good and polite person. He's just silently waiting. Here we are, the same task, the same photo, and Grok must show us some. Do we have any choice? Out of fast expert, and we are doing the, what we are doing? We are doing the expert, I think. So thank you, Copilot. Yes, last time it was expert. So go back to Grok. Not this Grok. Grok is here. Expert. Please, expert. Dear expert Grok, go ahead and tell us about the count. But in the meantime, and again, you can see the process of work and what Grok is doing. In the meantime, we are checking what has been done last time. So, and you see it took 7 minutes, 54 seconds. So, yes, it will be late night when we will finish. But no worries, we have this time. It's a Saturday evening, a nice time to wait until Grok will give us some hopefully accurate, consistent results about the blueberry count, because I think it will be now. Yes, it's now. Basically, I have this reminder when I need to remind you what we are doing here. So we are testing. Oh, just again, sorry. I need to set up this timer again, because I hope in the next 15 minutes we will finish, but we don't know what Grok will show us. So let's just have another reminder. But yes, we need to finish because it's so late already, almost half to 10. What we are doing here? AI assistants, we all know them. We are testing them on accuracy and consistency of the results for counting and measurements of the biological objects called blueberries. Oh, blueberries are here. I would like to share this with you right now, but not now, because screen, we still don't have this opportunity for teleportation of objects, or maybe I just don't know about them. But yeah, so blueberries, we are counting and measuring blueberries using the same photo, the same prompt for the AI assistants, and we are asking to help us with specific numbers. And we're also using this, just give me a second, this calibrating plate. I already explained at the beginning, and after the end of this session, it will be recorded, and on YouTube, I will place it soon, so you can watch our nice conversations with the ChatGPT, Gemini. Then we also had Claude. We also had Copilot, and this is the final. Grok. Still thinking, because it's just 2 minutes. 2 minutes of the process, and the last time it took 7. So that's why we need to wait a little bit more. And then we will read the results and compare them with the benchmark, which is Petiole Pro, as well as with the previously delivered results. And it's even less than 7 minutes. Oh my God, these numbers are not right. 439 after excluding the 15 Yeah, I see that 439, it's something unbelievable, and it's something definitely wrong because we have 229. So this means that in Grok's opinion, we have 210 blueberries more in the photo. So we will ask him now. In the meantime, where is our prompt? Here. So we will ask him to deliver us the segmentation. So at least we will see the objects which has been counted. But I mean that number is already wrong. So let's go to the mean area and mean perimeter. Again, I see the similarity with Claude, but it's too small. 0.26 square centimeters and 1.90 centimeters is perimeter. It's way too small in comparison with what we have in real blueberries. This blueberry is more than 0.26, and it's just not normal. It's definitely undersize berry produce with these sizes. And then that's why I'm not looking at area perimeter correlation, because I see that area at all is not correct. And let's see, maybe wow. But this is nice. So why? This is the same question like we asked Gemini. Why the total count is that wrong? Maybe I need, here is Gemini. And this is the Grok. You look at this beautiful segmentation, and I need to save it again. It's just too beautiful to be forgotten. No, I have said somewhere else, sorry. Oh, because it's a different format, that's why I don't see it. But anyway, I will just do like this, and then we'll do like Grok 2803 2026. Good, then I will prepare it in that way. But this is, again, you can just analyze what has been done. So I wanted to make it bigger. Oh, I know. We will open download it like this one, and open straight from here. We will be able to see the segmentation. It's a masterpiece. I think it's computer vision masterpiece. Honestly, it's very beautiful, but the count is not correct. 439. So segmented, as you see, there are no errors in segmentation. So there is excluded calibrating plate, and then there are all the berries. I don't want to recount them here and now. Maybe on one day we will do this recounting, but not 229 berries. It's too much for now. No, I'm not ready for that mentally. But I'm not sure why. The segmentation is right, but the final result is not right. But we will definitely save this. Maybe I will do some LinkedIn post about this. I will think about this opportunity. But yes, that's really nice. So regarding consistency, we wanted to finalize the part. So last time it was less than 229, and now we have almost 2 times more than 229. The mean area was undersized and mean perimeter was undersized, and here we see the consistency in being wrong. So, and as I remember, this is the final point, because this is the result which we delivered using my experiment, which I had done firstly. Today's results, I think we will have this nice visualization of first. Where is it? Just a second. Here. Oh, I need probably to just to make this nice. Bring it here as well. Oh, yes. No, just a second. Here as well. So now we have. Firstly, we had ChatGPT. ChatGPT was here. This is the visualization of berry count, blueberry count, which we got from ChatGPT, and it was not correct. Then we got Gemini, and Gemini was where is Gemini? This one, I think. Just give me a second. Yes, then we have this very beautiful and minimalistic segmentation from Gemini. No words to say that it's really nice and correct, actually. So that's why I'm not sure why the final detection was wrong. Then we had a nice and beautiful Claude here. So we can ask him to download, because I see that I didn't download it. Here is the analysis. And it's still visually nice and beautiful, but absolutely not correct. And as a cherry on top, we had such an impressive result from Grok. Here it is. And this is probably the final point, because we cannot compare the table of benchmark and table for consistency. They were wrong regarding this, but this again explains why the models has to be customized. So we are using the generally available models, which are not specifically developed for the task of either blueberry quality control or any type of specific measurement and assessment. So we are providing the input, general input, but we try to be to give more specifics to this input. But the model by itself, it's not ready to work with that level of specifics. So that's why the customized models, which are ready to work with that level of specifics, they can deliver that accurate result which you are expecting, and which can be applicable and consistent for the processes like, for example, quality control. You need to do it with our use case, which we have as real farm. They are doing quality control on daily basis. So that's why they need to do this measurement and counts on daily basis and deliver the average results at the end of the day. And even there is a specifics that they don't have internet, so the model is run on the mobile device, and at the end of the day it's synchronized in the general system. But again, it's a separate story. Yes, and when I was planning to do this live stream, I also was thinking that, maybe I will show you the video which I was demonstrating at the Bridge AI exhibition, because it was about blueberries and counting and everything, but it's a little bit late, so maybe next time or any other day, but I will show you that video. So let's double check. Do we have all the pages? Yes, so this is our, as I mentioned, our mosaic of blueberries, which has been counted by Petiole Pro. And this is my general message and our vision about the batch processing of imagery, which can be helpful and insightful in terms of bringing the numbers into the game, and you can work with them and make your decisions more data-driven. And on these nice words, I still show you my blueberries, and I say thank you for being with me for 1 hour and 33 minutes. And yes, we will continue, definitely. Next Saturday, it will be April already. Just give me a second, I will double check, is it April or not April? Because yes, I think it's March flies very quickly, and next Saturday is the 4th of April. So we will meet again, and I will bring you some other interesting things to do, to think about. And as of now, again, the magic of switching the screens
no, I will not switch the screen. I will do like this. Oh, because I am so experienced in understanding that the fail is here. So if I will try to switch my screen, then it will be maybe frozen, and I don't want to make it again possible. So I want a smooth, nice end of this very good session with blueberries, with our permissible indulgence. I wish you a lot of blueberries and positive emotions, and yes, stay in touch. Thank you so much.